Welcome to the e-Pathshala lecture series on computer science for postgraduate students. We had a course already. This course is about computer graphics and visualization. We had a session already, and this is the second session on computer graphics and visualization. In the last session and the previous session, we talked about some of the very basics and terminology and the required background for this course. And today in this session, we are going to talk about the DDA line drawing procedure. So, and we will continue further with the circle drawing, the other line drawing procedures like Bressenham and so on. So, we will start with the DDA line drawing procedure, followed by that will be the Bressenham's line drawing procedure, and followed by that is the circle drawing procedure. So, hope you remember all that we discussed. That will be really useful for this session as well. Let us continue with this second session today. First thing about graphics is that any picture is made up of a combination of some of the basic building blocks. We call them basic building blocks because a picture is made up of some of the many of these are a combination of these basic primitives. We call them primitives because they are combined in some form or in some manner to form bigger pictures. So, we call them the 2D output primitives. So, we mean to say that it is 2D because we are dealing now with the 2D graphics. In the future, we will be talking about, in future sessions, we will be talking about 3D graphics as well, and there also we will be discussing about some of the 3D primitives. So, basically a primitive is something like a component of a picture. So, a picture can be considered to be made up of a combination of many graphic primitives. Some of the primitives are listed here, as you can see. One is points, the fundamental primitive, followed by that are the lines, the triangle, the planes, the circles, the ellipse, the arcs, splines, NURBS, fractals, and there are many more such primitives. So, you can think that a picture can be made up of a combination of these basic primitives. As you all might have experienced while using computers or while using a word processing software like MS Word, you might have actually taken some of the line art, some of the lines while you are doing some drawing, while you are doing. So, you could draw a line, select a line, draw a line. You could choose a shape like an ellipse and just make it bigger, and you could actually color it and do much more to it. So, a picture is basically a combination of all these basic primitives, as we can. So, how do we represent these things in a program or in a machine? So, that is what is our the discussion that is going to happen today. So, how do we represent these basic primitives so that later we can combine them to form various pictures? So, to start with, the fundamental primitive is a point. So, a point is actually a location in space, and it has no dimension, as we all know that theoretically a point has no dimension. But so, a point has got a location, so which can be plotted as, say, for example 4, 5 and so on. So, it has a location, and a line is basically a collection of points along a particular direction. So, when you extend a series of points along a particular direction, so we call that a line. So, basically a line is a collection of points along a particular direction. So, in graphics or in display devices, we basically we can think of a line as a series of points which are basically series of pixels. Okay. So, one important thing that we should remember is that the monitor is a device which has got a rectangular arrangement of pixels, and a pixel is identified or located using some x coordinate and a y coordinate. So, some x position and y position. So, as we know that on monitors the x positions and y positions that we refer to are actually as integers, and there are no floating point values. For example, you cannot plot a pixel on a monitor for value like say 4.5 and 5.7, there is no such pixel on the monitor. So, you have to either round it off, or you can have only integer positions on the monitor. That is an important observation. Okay. So, let us see what a line is, and we have just seen what a line is, and how do we draw a line in a program, or how do we represent a line in a program. So, as we just discussed before, a line is basically made up of a series of pixels along a particular direction. So, the most popular line drawing procedures that existed in the literature are the DDA line drawing procedure, one of the most rudimentary level procedures, which expands to digital differential analyzer, and the second well known procedure for line drawing is given by Bressenham, he is a scientist. So, these two algorithms will be discussed in this session. So, followed by that the circle drawing procedure. So, let us start with the DDA line drawing procedure, and as I said, an algorithm or a program is like what is expected from a program or an algorithm or a procedure is given two endpoints, and the procedures have to compute all possible and accurate positions between the two endpoints for the given line slope or inclination. So, we also want algorithms that should be efficient. So, efficiency is in terms of the number of resources, the type of resources that they consume. So, they should be less complex and should be well behaved and should also give us accurate lines when we draw them. So, the first line drawing procedure that we are going to talk is about the DDA line drawing procedure. So, this is based on the slope point form of line equation. So, it assumes that a line is represented basically as a slope point form. As you know, a line can be represented as a slope intercept form. In slope intercept form, a line can be represented in slope point form. A line can be also represented in parametric form. So, we assume here for the DDA procedure that the line is represented in slope point form. So, this algorithm is the most simplest and rudimentary level procedures, and it is also a scan conversion based procedure. As you might remember that we were talking about the scan conversion. The process of scan conversion is something like this. The algorithms give us a set of values, and the process of scan conversion is to represent a matrix of values, so that we can finally put it on screen. So, a program, the steps in a program are basically converted to a set of pixel intensity values, and that is called scan conversion, and the device or the hardware that does this is the display processor. If you recollect the discussion of the previous session, you would be able to appreciate all this. So, and it should be and the unfortunate thing, that is the drawback of this procedure, is that it is less efficient, as we will note its drawbacks. So, let us start with this procedure, this DDA line drawing procedure. We can imagine various types of lines that exist. So, for example, if you could see here, the line type 1 is actually it starts with the dots indicate here, the circles at the end indicate that there is a light blue color dot here and a red color dot at the end. So, that indicates the starting and ending points of a line. So, the algorithm's input should be the starting and ending points, and the algorithm should compute all the in between points that make up the line. So, now the line type 1 is you can observe that this is more inclined towards x axis. So, see the inclination here. So, it is more inclined towards x axis. So, that is, it is more bent towards x axis. Line type 2, you can observe that the line is more inclined towards y axis. Line type 3, if you see, it is also more inclined towards x axis. Line type 4 is close to as similar like line type 2, which is inclined towards y axis, and line type 5 is actually a type of line whose slope is exactly equal to 1. So, as you could see here, the slopes are given here. The important thing that you should observe is for line types 1 and 2, the slopes are positive. What do you mean by positive slopes? While x increases, y also increases. While x decreases, y also decreases. So, these types of slopes are considered as positive slopes. So, when we move from the starting point to the first point to the last point, that is the first point to the other end point. If the slopes are positive, that is dy by dx is basically positive. For line types 1 and 2, the slopes are positive, but for line types 3 and 4, the slopes are negative, and the slopes also have values here less than 1, greater than 1, as you could easily you can observe this kind of behavior. So, these are the possible lines that we can imagine in the 2-dimensional space. So, let us try to find procedures that can compute points along the lines of various line types that we have just seen. So, as mentioned here, the line types 1 and 3 are more inclined towards x axis. So, the important observation is that we can sample them along x axis at the best possible sampling frequency, which is 1. So, that is 1 unit here. See, imagine you have lines which are more inclined towards x axis. So, our aim is to actually sample the line along x axis at the best possible sampling frequency, and that is actually 1 unit. That means, start from the first point on the line, first end point, and take sample values of 1 unit and go till the last point, that is the other end point. So, similarly for line types 2 and 4, because they are more inclined towards y axis, it makes sense only to sample them along y axis at the best possible sampling frequency, that is actually 1 unit. See, you can also sample at 2 units, 3 units, 4 units and so on, but as we know very well that the higher the sampling frequency, the better is the approximation for the true line. Okay. So, that is where it is interesting, the possibility, the highest possible sampling frequency is actually 1 unit. So, because as we know very well that no in between points can exist on a monitor, on a display device. So, we can only choose integer positions, and the difference or the distance between any two consecutive positions is actually 1 unit on a display device. As you know, that is how the pixels are arranged on a display device like a monitor. So, imagine a line with slope m less than 1, that means the line is now more inclined towards x axis. So, we will start our sampling along x axis at unit steps starting from the first point and till the last point. So, assume that we are given the 2 points. So, for example, say like P 1 is a given point 2, 1 and P 2 is the other end point of the line, say 9, 4, and both are given, and our aim is to actually compute all the other in between points that make up the that fall along the line path. So, as I said, the distance, that is we are going to sample this line along x axis, because the line has a slope less than 1, indicating that it is more inclined towards x axis. So, it is mentioned already that 1 and 3, the line types 1 and 3 both show a case where the lines are more inclined towards x axis. So, we will be sampling them along x axis at unit intervals. So, the steps go like this: increment x values by 1 unit and compute the corresponding y values using the slope point form of a line. So, what is that we will be doing is, we will be starting with the first point, that is we will keep incrementing the x values by 1 unit, because we can only sample the line along x axis at unit intervals, and that is the best possible sampling frequency, and the corresponding y values are computed using the slope point form. Similarly, for the case m greater than 1, here modulus is considered, because whether it is positive or negative slopes, here you should notice that line type 2 is a line whose slope is greater than 1 and is positive. For line type 4, the slope is modulus of the slope is greater than 1, but m is negative. So, because we are starting here and we are ending here. So, for line types 2 and 4, we will be sampling the line along y axis, okay. So, at unit intervals, and we will be computing the corresponding x values. So, that is how we go with these steps. So, if you look at these steps here, and given the 2 endpoints P 1 x 1 y 1 and P 2 x 2 y 2, As you know, slope can be computed using the simple equation y2 minus y1 by x2 minus x1, which is nothing but the difference delta y by delta x. So, any two consecutive points along the line also satisfy the same property, that is the slope, if you compute taking any two consecutive points on the line also gives us the same slope. So, if you look at this second step here, for any two consecutive points along the line, say x k y k and x k plus 1 y k plus 1, they are two consecutive points. If you compute the slope, that is take the y difference and divided by the x difference, and we get delta y by delta x, which is actually the same as del y by del x. So, both actually are the same. So, here k takes integer values from 1 or 0 for the first point and increases by 1 unit. Okay. So, k will start with the first end point and keep moving till the other end point. So, here take these equations, the previous equations you should remember, so that we will be using them for calculating the steps to follow. So, assume that m is less than 1, less than or equal to 1, that is m is either positive or negative. So, as I said, our aim is to compute next x value and next y value. So, given the first end point, we are starting with the first point, which is a known point on the line, and we will be actually computing the next x and y value, the next x and y value, the next x and y value till we reach the other end point. So, we indicate the next x value notation x k plus 1, we indicate the next y value with the notation y k plus 1, k plus 1 all in the suffix, k plus 1 all in the suffix. And in this case, as we assume that the slope is less than 1, we are actually sampling the line along x axis. So, as we understood earlier that for inclined lines which are more inclined towards x axis, we are going to sample the line along x axis at unit steps. That means, every next x value is exactly 1 unit at 1 unit distance from the previous x value. So, the next x value, that is x k plus 1, is nothing but previous x value plus 1 unit. Okay. So, but the next y value is actually y k plus m. How did we get this y k plus, the next y is nothing but previous y value plus m units. So, how did we get this equation is, you can look back in the previous slide. What is that you can do is, for next y, to compute next y, what is that we do is, in this equation, as we know that next x value is x k plus 1, as from this relation x k plus 1 is equal to x k plus 1, substitute in this equation for m, x k plus 1 is equal to x k plus 1. So, the denominator remains, that is x k plus 1 minus x k. So, x k gets nullified and you are left out with 1 in the denominator. So, m is equal to y k plus 1 minus y k. So, which is nothing but y k plus 1 is equal to y k plus m is what is this equation. So, that is how we get the second equation here. So, we call this 1 as the increment for x, we call m as the increment for y, and these equations, as you notice, are recursive in nature. That means, every previous value is taken for computing the next value. So, unless we start with a known point on the line, we cannot compute the other points on the line. So, come to the case 2, where we assume that the line slopes are greater than 1. That means, you recollect the line types 2 and 4. So, they have slopes greater than 1. If m is positive, what does that mean? If m is positive, is the line type 2. So, for line type 2 here, m is positive. Okay. So, what is that we can do is, as because the lines are more inclined towards y axis, we will be sampling the line at unit y values along the y axis at unit y intervals. So, the next y value is 1 higher than the previous y value. So, y k plus 1 is equal to y k plus 1, and substitute this relation, this equation, this value of y k plus 1 in this slope equation. So, replace this, substitute for y k plus 1, y k plus 1, and the numerator then becomes 1 divided by x k plus 1 minus x k. So, we are interested to compute the value for x k plus 1. So, x k plus 1 is equal to x k plus 1 by m. This is how we get the next x value. So, for slopes greater than 1, the next x value is previous value plus the increment value is 1 by m. For the next y value, it is actually 1 higher than the previous y value. So, in the case if m is negative, so we have to check for all cases. First, given a line, we should check for all possible cases, m greater than 1, m less than 1, whether m is positive or m is negative. Accordingly, we should be choosing the set of equations for computing the next x and y values. So, if m is negative, you can come to this case. If m is negative, so what is that you can do is the next x value is actually x k minus 1 by m, and the next y value is y k minus 1, because you can now recollect the line type 4. The line type 4 is actually a line whose slope is negative. Here x is increasing while y is decreasing. So, here there is a mistake in this equation. So, you can make it plus. It is next x value is x k plus 1 by m, but the next y value is y k minus 1, because as you see here the line type 4, its x value is increasing while its y value is decreasing. So, y is decreasing by 1 unit while x is increasing by 1 plus m. So, you 1 by m, sorry, it is 1 by m. So, you can take this equation here as x k plus 1 is equal to x k plus 1 by m. So, let us come to the third case. So, we have seen 2 cases here. Let us come to the third case. If m is less than or equal to 1, that means again imagine the line types 1 and 3, and if starting and end points are reversed, what would you do if starting point and end point are just the reversed, just in the reverse manner, that is both x and y are decreasing for line type 1 and 3. So, line types 1 and 3. So, that is these equations will tell you. So, both x and y are decreasing. So, x is decreasing by a value 1, y is decreasing by a value m. So, that is how we take this. And case 4, if mod m is greater than 1 and if starting and end points are reversed. So, what happens actually is imagine line type 2 and 4. So, as you could imagine line type 2 and 4 whose slopes are greater than 1. Now, these equations say that the for m positive case both because the end points are reversed, both x and y values get just the values get reduced by 1 by m for x k for x and 1 for the y. For m negative, in case if mod m is greater than 1 and m is negative. So, either x or y will be decreasing, one of them will be decreasing, the other will be increasing. So, in this case you can consider this to be negative. So, y k plus 1 is equal to y k minus 1, or one of these will be negative, as I have represented here. So, you can correct this. So, one of these should be negative. So, this DDA line drawing procedure is actually as simple as given 2 endpoints, and that is the first step is to get the input, which is in the form of 2 endpoints. So, we start with the first endpoint, compute the slope and check if the slope is positive, negative, or its magnitude is less than 1 or greater than 1. In program or while you do your program, do not actually check or take the division. Instead, you can actually check m is equal to dy by dx is the standard equation. Then to take a division like dy by dx, what you can do is you can check if dy less than dx or dx greater than dy. Accordingly, you can check your slope. Okay. So, that means if dy less than dx, so that means m is less than 1. Okay, that is how you can. If dy greater than dx, m is greater than 1. So, in that manner you can do your comparison, than to actually take a division of dy by dx and then making it checking it for less than 1 or greater than 1 or equal to 1 and so on and so forth. So, while you do your program, take that care, because sometimes if you have to draw lines which are horizontal or vertical, one of the dy and dx, either of the dy or dx becomes 0. So, what actually happens is your denominator or numerator becomes 0. So, if the denominator happens to become 0, that means if you have to draw a vertical line, dx becomes 0, and if you take dy by dx, it becomes infinite and your program hangs. So, what you do is than to take the division dy by dx, better compare the values of dy and dx. Okay. So, the algorithm is summarized here as shown in the slide. So, input the endpoints. So, get the two endpoints, compute the slope, the second step. Depending on the magnitude of the slope, and we can decide which of the procedures to adopt, or which are the equations to actually adopt. And the final step is to actually, as we discussed just before, that your monitor, our monitor is something where there are only integer pixels or integer positions. We cannot actually plot points which are decimals. So, we have to round it off while plotting. For all our computations, you can use floating point values, but while plotting we should round it off and plot. So, an example is given here. Given the two endpoints, say 2, 2 and 10, 5 are the two endpoints given. As soon as the endpoints are given, so find the position, find the intermediate points using DDA line drawing procedure. So, as the first step, immediately you can check the slope. So, if you notice that the slope is m is equal to 3 by 8 y 2 minus y 1 by x 2 minus x 1, it gives us 3 by 8, which is actually 0.375, which is less than 1. So, the first observation is that m is less than 1. So, and this is also positive. So, this indicates that we have to sample the line along x axis at unit intervals. So, x increment is 1 and y increment is m, as you could remember from the previous equations as case 1. So, m is less than 1 and m is also positive. So, these equations are to be used for computing the next points on the line. So, to start with x naught y naught, so that is the starting point, as we can give a notation x naught and y naught to indicate the starting point, and which is also the known point on the line. So, the next point is actually, as we know that x gets incremented by 1 unit, what you can straight away do is increment the x coordinate by 1 unit, 3, 4, 5, 6, 7, 8 and the last point. So, that is we are given the points 2, 2 and 10, 5. So, x coordinate varies from 2 to 10, while y coordinate varies from 2 to 5. So, the x coordinate gets incremented by 1 unit. So, 3, 4, 5, 6, 7, 8, 9, and we have to compute the y coordinate using the equation y k plus m. Take the previous y value, add m to that, and m is a fraction here which is 0.3, so that is 3 by 8, that is 0.375. So, here the next y value is computed. Take the previous y value, that is the first y value is 2, add 0.375 to it, and where you get 2.375. So, 2.375 is what is actually listed here in the table, as you could see here, and add 0.375 to 2.375, which is 2.750. So, we can keep adding the previous y value the m, so that you can compute all the possible y values, but these points cannot be plotted on the monitor, as we know that monitor has got only integer positions. So, 3, 2.3.75 cannot be plotted. So, what is the possibility? So, you need to round it off. So, 3, 2 only can be plotted. So, when you round it off to the nearest integer, so you can use some round function, okay, and you can round this value 2.375 to 2. So, 3, 2 is the point that we will be actually plotting. Similarly, 4, 3 is the point that we will be actually plotting. When you round off 2.75, it is 3. So, similarly, when you round off other y coordinates, we get 5, 3, 6, 4, 7, 4, 8, 4 and 9, 5. So, for this line, if this is the theoretical line that is actually getting plotted, which cannot be actually plotted on the monitor. This DDA line gives us coordinates. See, there are 2, 2 is the first point and 3, 2 is the next point. So, 2, 2, 3, 2, 4, 3, 5, 3 are the next 2 points. So, 4, 3, 5, 3 are the next 2 points. Then 6, 4, 7, 4, 8, 4, 3 consecutive points which are on a straight line, which are like this and which are. So, this shape is actually called a stair step or Jaggi effect. So, if you observe this line on a low resolution monitor, you would notice that the line is actually not nicely smoother and inclined as a nice theoretical line. It is actually like staircase steps. It is like a steps, because 2 points, consecutive points are along a line, then 2 consecutive points are along the next line and 3 consecutive points along a line and so on. So, this kind of points as we get because of the DDA procedure, because of rounding it off, is called a stair step or Jaggi effect, which we do not like or which is not appealing for a typical line. So, that is one drawback. The second drawback is floating point calculation. So, we are taking care of so much of floating point decimals, floating point calculations, and which also always are rounded off. And for longer lines, the DDA line drifts away from the true line. For the longest, if you try to draw the longest possible line on the monitor, say from the top left corner to the bottom right corner, or you can try drawing from the left to the right inclined lines, you would notice that there is a drift from the theoretical line. So, that is how about the DDA line drawing procedure, the most simplest procedure. And in this, what we have learned is how to draw a line given 2 endpoints and how does the DDA line drawing procedure works. And we have solved an example problem to understand what it does, and we have also taken a note of the drawbacks of this procedure. So, let us conclude this session here. Thank you.